My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Operations Research as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 5 first important short question is: what is game theory? Game theory. Game theory is a part of operations research that studies how people or organizations make decisions in competitive situations. It provides mathematical tools to analyze conflicts where the outcome depends on the actions of two or more decision makers, called players. Each player has different strategies, choices, and the result of the game is called a payoff, profit, loss, or utility. In many cases, one player's gain is exactly the other player's loss. This is called a zero-sum game. Example: suppose two companies, A and B, are deciding whether to advertise or not. If both advertise, profits reduce due to high costs. If only one advertises, it gains more customers. If neither advertises, both save money. By using game theory, each company can choose its best strategy to maximize profit while minimizing risk. Easy trick: game theory is equal to players plus strategies plus payoffs is equal to smart decisions. Next important short question is: 2. Define pure strategy and mixed strategy. Pure strategy and mixed strategy. In game theory, a strategy means the plan of action chosen by a player to achieve the best outcome. 1. Pure strategy. A pure strategy is when a player always follows a fixed action every time. There is no randomness or change. Example: if company A always chooses to advertise, no matter what company B does, it is using a pure strategy. 2. Mixed strategy. A mixed strategy is when a player does not stick to one fixed action but instead chooses among two or more strategies with certain probabilities. This adds uncertainty and prevents the opponent from predicting the move. Example: a cricket bowler sometimes bowls a fast ball, 70%, and sometimes a spin ball, 30%. The batsman cannot easily guess the next ball. Easy trick to remember: pure strategy is equal to fixed plan, like always choosing rock in rock paper scissors. Mixed strategy is equal to randomized plan, sometimes rock, sometimes paper. Next important short question is: 3. What is saddle point in game theory? Saddle point in game theory. In game theory, a saddle point is a special position in a payoff matrix where the chosen strategy is the best for both players. It gives a stable solution to the game because neither player can improve their payoff by changing their decision. To find a saddle point, look at the minimum value in each row, row minimums. Look at the maximum value in each column, column maximums. If a value is both the maximum of its column and the minimum of its row, that value is the saddle point. Example: suppose player A versus player B payoff matrix. B1 B2. A 1 4 6. A 2 to 5. Row minimums is equal to 4, 2 max is equal to 4. Column maximums is equal to 4, 6, min is equal to 4. So, 4 is the saddle point. Easy trick: saddle point is equal to row max of row min is equal to column min of column max. Next important short question is: 4. State the dominance property in game theory. Dominance property in game theory. In game theory, the dominance property is a rule used to simplify a payoff matrix. It states that if one row, strategy of player A, always gives equal or better payoffs than another row, then the weaker row can be eliminated. Similarly, if one column, strategy of player B, always gives equal or worse results compared to another column, then that column can be removed. By applying dominance step by step, the matrix becomes smaller, making it easier to solve the game. Example. Suppose player A's payoff matrix against player B is B1 B2, a 1 5 7, a 2 3 6. Here, a 1 always gives better payoffs than a 2, 5 3 and 7 6. So, a 2 is dominated by a 1 and can be removed. Easy trick, dominance is equal to cut down weaker rows columns smaller matrix easy solution. Next important short question is 5. Write any two limitations of game theory. Limitations of game theory. While game theory is useful for studying competitive situations, it also has some limitations. 1. Assumption of rationality. Game theory assumes that all players are perfectly rational and always make logical decisions to maximize their payoffs. But in real life, people or companies may act on emotions, habits, or incomplete information. Example, a company may cut prices suddenly to hurt a rival, even if it reduces its own profit. 2. Difficulties with large problems. Game theory works well for small games, 2 times 2 or 3 times 3 matrices, but real-world business problems may involve many players and strategies. In such cases, the analysis becomes very complex and time-consuming. Example, in global markets with many competitors, it's almost impossible to prepare a full payoff matrix. Conclusion. Thus, game theory is a powerful tool but not always practical, as human behavior and real-world complexity cannot be fully captured in simple mathematical models. Easy tip, remember, to rational, to complex is equal to limitations of game theory. Next unit we. Top 4 long questions. First important long question is: solve a game using pure strategies with the help of a payoff matrix. Problem: payoff to player A. Two players, A, row player, wants to maximize payoff, B, column player, wants to minimize payoff. Payoff matrix, rows is equal to a 1, a 2, columns is equal to B1, B2. B1, B2. A 1, 4, 2. A 2, 3, 1. We must check if a pure strategy equilibrium, saddle point, exists. Step 1. Row minima, A is worst if that row chosen. Row A1 min is equal to 2 because min 4 2 is equal to 2. Row A2 min is equal to 1 min 3 1 is equal to 1. Max of row minima is equal to max 2 1 is equal to 2. Step 2. Column maxima, BS worst for that column. Column B1 max is equal to 4 max 4 3 is equal to 4. Column B2 max is equal to 2 max 2 1 is equal to 2. Min of column maxima is equal to min 4 2 is equal to 2. Step 3. Check for saddle point. Since max, row minima, is equal to 2 and min, column maxima, is equal to 2, they are equal. So a saddle point exists and the value of the game is equal to 2. Which cell gives 2? Look at entries. Cell A1B2 is equal to 2. This cell is the saddle point. It is the minimum in its row and the maximum in its column. Conclusion: pure strategy solution. Player A's optimal pure strategy: choose a 1. This guarantees A at least 2, because B will pick the column that minimizes A's payoff. Player B's optimal pure strategy: choose B2. This limits A's payoff to 2, and B cannot do better by switching. Value of the game is equal to 2. Easy way to remember. Find row minima, take their maximum. Find column maxima, take their minimum. If equal saddle point pure strategy equilibrium. Next important long question is 2. Describe the graphical method for solving 2 times n or m times 2 games with an example. Graphical method in game theory. When a game does not have a saddle point, pure strategies cannot solve it. In such cases, we use mixed strategies. For 2 times n or m times 2 games, the graphical method is very useful because one player has only 2 strategies, which can be represented on a straight line, x-axis. If player A has 2 strategies, 2 times n game, we draw graphs of A's expected payoff for different strategies of B. If player B has 2 strategies, m times 2 gain, we draw graphs of B's expected loss for different strategies of A. The point of intersection gives the equilibrium mixed strategy and the value of the game. Steps. 1. Assume player A plays strategy a 1 with probability P and a 2 with probability 1 P. 2. Write the expected payoff equations for each column B's choices. 3. Plot them on a graph for 0 less than or equal to P less than or equal to 1. 4. The point where the curves intersect gives the optimal probabilities and value of the game. Example. Payoff matrix to player A. B1 B2 B3. A 1 2 4 6. A 2 5 3 1. Let probability of a 1 is equal to P, a 2 is equal to 1 P. Expected payoff if B plays B1, E1 is equal to 2P plus 5, 1 P is equal to 5, 3T. B plays B2, E2 is equal to 4P plus 3, 1 P is equal to 3 plus P. B plays B3, E3 is equal to 6P plus 1, 1 P is equal to 1 plus 5P. Now, plot E1, E2, E3 against P, 0 to 1. The lower envelope of these lines represents A's guaranteed payoff. The highest point on this lower envelope gives the value of the game. Suppose intersection occurs at P is equal to 0.5, then A plays a 1 with 0.5, a 2 with 0.5. The game value can be read from the graph, say 3.5. Conclusion. The graphical method is a simple way to solve 2 times n or m times 2 games, especially in exams. Easy tip. Think of it as draw payoff lines, find intersection, get mixed strategy plus game value. Next important long question is 3. Explain how the linear programming approach is used to solve game theory problems. Linear programming approach in game theory. When a game has no saddle point, we cannot solve it by pure strategies. In such cases, we use mixed strategies. But finding probabilities for mixed strategies directly is difficult. To make it easier, we use the linear programming problem (LPP) approach. The idea is simple. Player A wants to maximize his minimum gain. Player B wants to minimize his maximum loss. Both problems can be written as LPPs and solved using the simplex method or graphical method. Steps for player A maximization problem. 1. Let A have m strategies and B have n strategies. 2. Suppose payoff matrix is given to A. 3. Add a constant k if any payoff values are negative to make them all positive. 4. Assume A uses probabilities x, x, xm for his strategies. 5. Formulate LPP. Maximize V is equal to 1z. Subject to a 11x1 plus a 21x2 plus m1xm greater than or equal to 1. A 12x1 plus a 22x2 plus m2xm greater than or equal to 1. For all n strategies of B. And x1 plus x2 plus xm is equal to 1, 11 greater than or equal to 0. Here, Z is equal to value of the gain and optimal excess give A's strategy. Example. Payoff matrix. B1 B2. A 1 to 4. A 2 3 1. Step 1. No saddle point. Step 2. A uses X for a 1 X for a 2. Step 3. Expected payoff if B plays. B1 2X plus 3X. B2 4X plus 1X. A wants to maximize minimum payoff. So LPP. Maximize V. Subject to 2X plus 3X greater than or equal to V. 4X plus 1X greater than or equal to V. X plus X is equal to 1, X greater than or equal to 0. By solving, we get X is equal to 0.4, X is equal to 0.6, value of gain V is equal to 2.2. Conclusion. The LPP method is systematic and works even for large games. Easy tip. Think of LPP in game theory as turning the gain into maths equations, solving, getting best strategy plus gain value. Next important long question is 4. Discuss in detail the steps to solve a gain using mixed strategies. Mixed strategies steps to solve with a simple example. When a game has no saddle point, players use mixed strategies, play actions with probabilities. The main idea, make your opponent indifferent between their pure choices so they cannot exploit you. Here are clear steps and an example. Steps. General. 1. Check for saddle point. If found, pure strategy solves it. 2. If no saddle point, pick the player with 2 strategies. If 2 times n or m times 2, or convert to LPE for larger games. 3. Let the player with 2 strategies use probability P for their first row strategy and 1P for the second. 4. Write the expected payoff of the opponent's pure strategies as functions of P. 5. Equate these expected payoff functions, make them equal, and solve for P. This makes the opponent indifferent. 6. Compute the value V by substituting P back into any expected payoff expression. 7. If needed, find the other player's probabilities. Similarly, use Q or use LPP for many strategies. 8. Interpret probabilities. They are the optimal mixing rules. V is the expected payoff. Example, 2 times 2. Payoff 2A. B1 B2. A 1 3 1. A 2 to 4. 1. Row minima, A1 1, A2 to max is equal to 2. Column maxima, B1 3, B2 4 min is equal to 3. No saddle point. 2. Let A play a 1 with P, a 2 with 1P. If B plays B1, EB1 is equal to 3P plus 2, 1-P is equal to P plus 2. If B plays B2, EB2 is equal to 1P plus 4, 1-P is equal to 4, 3T. 3. Make B indifferent, set P plus 2 is equal to 4, 3T. Solve. P plus 3T plus 2 is equal to 4, 4P plus 2 is equal to 4, 4P is equal to 2P is equal to a half is equal to 0.5. 4. Value V is equal to P plus 2 is equal to 0.5 plus 2 is equal to 2.5. 5. For BS mix, let B play B1 with Q. EA1 is equal to 3Q plus 1, 1-Q is equal to 2Q plus 1. EA2 is equal to 2Q plus 4, 1-Q is equal to 4, 2Q. Set equal, 2Q plus 1 is equal to 4, 2Q 4Q is equal to 3Q is equal to 0.75. Result, A plays a 150% and a 250%, B plays B 175% and B 225%, gain value is equal to 2.5, expected payoff 2A. Memory tip. Indifferent is equal to optimal, make opponent indifferent, solve for probabilities, read the value.